and there's some other instructors that I'm having due for this week. I'm just following the schedule. So I am going to do the exam review. Exam to review. And if you already took the exam, maybe it can be worse to stay and actually try to learn something, because some of this stuff will be on the final. Okay. So I am going to cover everything for chapter 6, 6.1, 6.2, 6.3, 6.4, 6.5, and 6.6. This presentation is a little bit long because some of the problems with the matrix, they're a little bit challenging. Okay, so what I did, I took some of the slides from the week 9, I think, presentation, which was 6.1 to 6.3, and then I took some from 6.4 and 6.6, and I kind of added some new material or some different problems. Okay, so that's what I'm going to go over. Okay, for example, this is something from 6.1. It says determine whether the given ordered list of numbers is a solution of the system of equations. So here, guys, we are going to plug in -1 and 3 to both equations. Okay. So it has to make it true. For both, in order for this point to be a solution for these two equations. Which means if it's true, that means that's where the two equations intersect. So first, I'm going to get equation number 1, and I'm going to plug in -1 for x and 3 for y. Right, then I evaluate, so I have 1 on the left side and 1 on the right side, so this is true. So since this is true, I go on to equation number 2. If this would have been false right here, if that wasn't, say it was like 0 equals to 1, we stop there. That means that that's not a solution. But since it's true, we move on to the second one. And we do the same thing. We're going to plug in -1 for x and 3 for y. So we have 9 equals 9, so that means that point is a solution for the two equations. Okay. Now I do the same thing for number 2. I'm going to plug in 2 for x and -0.5 for y. And again, this is called equation 1, equation 2. So on equation 1, I'm going to plug in the values for x, which is 2, and the value for y, which is -0.5. After we evaluate, we get -3 equals to -3, so this is true, so we keep going to the second equation, which is x plus 5y equals -5. And again, we repeat the process. We plug in 2 for x and -0.5 for y. If you notice, guys, on the left side, we get -0.5, but on the right side, we get -5. So this is not true, right? So that means that this point, the 2 -5, is not a solution to the system of equations. So that's not a solution. Number one, it's yes, and number 2, it's no. Now, graphing is they describe graphing in the 0324, but in 1324 they don't really do too much about graphing. But I'm going to do it anyway, just to help the students taking 0324. And if you take 1325, which is the one that precedes 1324, you have to know how to graph. Okay, so that's why I'm going to do it anyway. Okay, I'm going to put graphing. Okay, here, guys, when we're trying to solve systems of equations, there's like different ways to get the answer. There's by graphing, by substitution, by the elimination method, by using matrix, and also by using the inverse matrix. So there's about 5 different ways. Okay, I'm going to show you each different method throughout these. Throughout this presentation. First, we're going to do it by graphing. Okay, if you guys recall from I think from chapter 1 or chapter 2 on 1324, this to graph, it has to be in y equals to mx plus b. So the m is my slope, which is 3, and we put it over the rise over the run, which is this is the rise, and the 1 will be the run. So if you have like an integer, put it as a fraction. Okay. And my b, which is a -6, is a y-intercept, which is 0, -6. And that's going to be my starting point. So my starting point is always the b, which is a y-intercept. So we're going to start right there at -6. Then it means that we're going to go up 3 and 1 across. So we're going to go 1, 2, 3, and 1 to the right. And then we draw our line. Then we do the same thing with equation number 2. we try to put it in the form of y equals to mx plus b, okay, which is called the slope-intercept form. So we have to isolate the y. Okay, so we start by adding 5x to both sides. After we add 5x to both sides, it'll be eliminated on the left side, and 5x minus 10, you cannot add them. I mean, that's why you put them how it is, 5x minus 10. Then we divide both sides by negative 2. So we divide both sides by negative 2, then my y is isolated on the left side. This will be negative 5 divided by 2, and this will be positive 5. Okay, so then what's my slope? My slope is negative 5 over 2. This can be negative 5 over 2 or 5 over negative 2. When it's in the middle, it doesn't mean that they're both negative. Only one can be negative, the top or the bottom, or you can put it in the middle. It's represented like in 3 different ways. Okay, and the b is my y-intercept, and that's my starting point. Okay, so we start there, right, at 0, 5. Then, here, guys, this can be minus 5 over 2, so this means it's going to go down 5 and 2 to the right. So from here, it's going to go down 5. 1, 2, 3, 4, 5, and then 2 across. 1, 2 to the right. And we draw our line. So this is my solution where they both intersect, which will be 2, 0. Where the point where both lines intersect is the solution, which is going to be 2, 0. Okay? Now, my next slide, I'm going to do the very same one by substitution. Just so you know that you can get it different ways. If the instructor for 1324 tells you to do it by graphing, you have to do it by graphing. But if they tell you to do it by substitution, you have to do it by substitution. You have to follow the rules of the instructor. For example, when I give exams, I tell them to solve by graphing, then solve by substitution, then solve by the addition method. And if they don't follow the procedure, I call it wrong, even though the answer might be right. Okay, because we as instructors want you to understand that there's different methods, and we want to make sure that you understand every method. So this one is done by substitution. Again, this is equation 1 and equation 2. So here, guys, we're trying to isolate one of the variables, either x or y. Since the y is already isolated on equation 1, we're going to substitute 3x minus 6 for y on equation 2. In other words, I'm going to substitute this, the 3x minus 6, into the y here on the negative 2y. So it's going to go in right there where the y is. Okay. So I leave my spacer because I'm going to substitute it right there, which means it's going to go right here. Then we do the distributive property, right? So it'll be negative 6x plus 12, and then we combine like terms on the left side, which would be negative 5 minus 6 will give us negative 11x plus 12 equals negative 10. And then this is just basic algebra. Then we subtract 12 from both sides, so it gives us negative 11x equals to negative 22. Hey guys, and the reason that I'm doing all the instructions, guys, because I don't want none of the students to get left behind. Because if I don't show you in green the steps, some students might say, well, how in the road did they go from here to here, and so forth. That's why here, guys, in green, it tells you what I'm doing. Now I'm going to divide by negative 11, both sides, so I get x equals 2. After you get the x value, then you have to find the y value, because it's an ordered pair. It has an x value and a y value. So here we need to find the y value, right? Because I already found the x. So I'm going to plug in 2, right? Because x is 2 for x, in either equation of 1 or 2. What is easier? In my opinion, 1 is easier because it's already the y is already isolated. So I'm going to plug in 2 for x. So it's going to give us 6 minus 6 gives us 0. So my solution is x equals 2 and y equals 0. Okay. That's my solution. Now, this is also from 6.1. I'm going to do the elimination method. For the elimination method, you have to set it up, both equations, 1 and 2, in the form ax plus by equals c. So for example, number 1 is not in that form yet. Number 2 is okay, but not number 1. So I have to work with number 1 and set it up in this form here. Okay, I need to rewrite equation 1 in proper form. So we have the x on the left side. Now the y must also go to the left side. So we're going to add 2y to both sides. Right, so we get x plus 2y equals 19. Now we have equation 1, which is the one that that we place in the ax plus by equals c form, and then we got number 2, which was already set in that format. Now here, guys, it doesn't matter what you want to eliminate, the x's or the y's. For example, since the x is already by itself or isolated, right? There's no coefficient there. It's easier to get rid of the x's because there's like a 1, there's like a coefficient of 1. So in order to cancel the x's, this must be negative 4x. So I'm going to multiply the whole equation by negative 4. Okay, so if we do that, it's going to give us negative 4x minus 8y equals to negative 76 because I multiply negative 4 times every term, times x, times 2y, and times 19. That's what it gives us. Now, since we're not going to do nothing with equation number 2, it stays how it is. If you notice, if we add them, right, the x's will be eliminated. So we got negative 8 minus 3 will give us negative 11y. Now we're going to divide both sides by negative 11. So we get y equals 7. Now we do the same thing as before. We need to find the x value. So we're going to plug in 7 for y, right? Because y is 7 and either 1 or 2. So here, guys, you can either go here at 1 or 2, or you can go to the 1 at the beginning. Because this one here at the beginning, the x equals to negative 2y plus 19 is the same thing as x plus 2y equals 19. So in my opinion, it's easier to go to number 1 here, but from the beginning, because the x is already isolated. So I'm going to plug in 7 for y in here. So it gives us negative 14. Negative 14 plus 19 will give us 5. So my solution is 5, 7. So 5, 7 is where these two intersect. That's what we're looking for. Okay, but not every time there's going to be a solution. There might be many solutions, or there might be no solution. Okay. The next example, or number 6, is going to be an example of, well, let's see, let's work it out and we'll find out. So here we have equation 1 and equation 2. So here it doesn't matter what we want to get rid of. So let's say we want to get rid of the x's. So to get rid of the x's, this must be negative 6x, right? Because when we add them, they'll be eliminated. So I need to multiply the whole equation, number 1, by negative 2. If we do that, this is the result, because multiply negative 2 times every term. And the second equation stays how it is. If you notice, on the left side, everything was going to be eliminated. Also on the right side. So we get 0 equals 0. Hey guys, when you have no more variables, but the left side and the right side, I mean, it's true that they're equal, then we have infinite solutions. So this has many solutions, which means it's one line on top of the other one. Okay, it's the same line on top of the other one. Number 7, we also want us to solve it by the elimination method. So again, this is equation 1 and 2. So if I want to get rid of the x's, I'm going to multiply this equation by negative 3. By doing so, it's going to give us negative 6x minus 15y equals to negative 24. And equation number 2 stays how it is. Then if we add them, you see that everything on the left cancels or is eliminated, but on the right side we get negative 6. But this is not true. This is not equal, right? That means there's no solution. Okay. So again, here we have plenty of practice of doing the elimination method. Okay, now how do we apply it like in real life situation? That's why I have to assign like a word problem guide. When I teach this class, I love assigning word problems because this way it tells me that if the students understands the concepts, if they can apply it like in real life, like a real life situation. So here it says, a 200-seat theater charges $8 for adults and $5 for children. If all the seats were filled and the total ticket income was $1,435, how many adults and how many children were in the audience? So here, guys, we need to do for the solution, we need to find 2 equations. So I'm going to say we're going to do seats with seats. Seats with seats because we have adult seats plus children seats equals to total seats, which was 200 seats. That's why it's going to be let x equal adult seats and y equals children seats. So there are 200 total seats. So that's my equation, x plus y equals 200. Now, for the money, I like to say keep money with money. So here is $8 for adults, correct? Since 8 equals to since tickets are equals to X, the adult tickets, that means it's going to be 8X. The children's tickets, right, are $5, and we're going to let that equal to Y. So it'll be 5Y, because the children's seats are Y. Now, the total revenue, or total income, is $14.35. So it's going to be 8X plus 5Y equals to $14.35. That's my second equation. So now I have my system of equations. Those are my systems. Then again, I like to number them. This will be equation 1 and equation 2. You see, guys, because when I actually teach this course, I don't like to say the equation x plus y equals 200. To me, that's too much verbiage. So if I say equation 1 represents x plus y equals 200, and equation 2 equals to 8x plus 5y equals to 1435, I can just say equation 1 or equation 2, right? Because we already know that equation 1 is x plus y equals 200, and same thing for equation number 2. So here, guys, again, it's better. This way you can do it by graphing, by substitution, or the elimination method. But in my opinion, it's already set up in the ax plus by equals c form. So that way it's easier or more convenient to do the elimination method. So here, it doesn't matter what you want to get rid of, the x's or the y's. Here, I decided to get rid of the x's. So this must be negative 8x, because negative 8x plus 8x is going to be 0. But I have to multiply the negative 8x to every term on the equation. So if I do that, this is my result. Negative 8x minus 8y equals to negative 16. And equation number 2 stays how it is. Now, if we apply the addition property here, guys, so this will be 0, right? So the x's are eliminated. That's why it's called the elimination method. But it's also called the elimination method, and there's some other authors that call it the addition method. They mean the same thing. So here we get negative 3y equals to negative 165. So we divide both sides by negative 3, and this is my result, 55. Now again, I have to go back and plug in y, 55 for y, and either equation, and solve for x. So it's easier to go in equation 1, because the x and the y, the coefficient is 1. Right, so I'm going to plug in y equals to 55. So then if I do that, then we're going to get x equals to 145, because we subtract 55 to both sides. So that means that x equals 145 and y equals 55. The x represents adult tickets, right? So that means those are going to be my adult tickets, will be 145, and the y will be children's tickets. So we have 145 adults in the theater, and we have 55 children also in the theater, which, if you add them up, it equals to 200. That's how you work these type of problems. Okay, now this is something from 6.2. These are called larger systems of equations. For larger systems, I came up with a plan last week, but for the sake of trying to cover more material, the plan was I'm going to get 1 and 2, equation 1 and 2, get rid of the x's, and then get equation 1 and 3, and also get rid of the x's. So here I will show you the plan, but I'm going to execute it, and I'm going to let you know what we're going to be doing as we go along. So I'm going to get these two equations, 1 and 2, and get rid of the x's. So here, right, to get rid of the x's, this must be negative 2. So I need to multiply the whole equation 1 by negative 2. In doing so, this is my result. Negative 2x plus 6y minus 4z equals 0. Equation 2 stays the same. After we add them, right, the x's are eliminated. So this is like my new equation 2. Now I'm going to get 1 and 3 and repeat the process. So here on number 1, this has to be a negative 3 in front of the x, so they can cancel, right? So I'm going to multiply the whole equation by negative 3. And as before, if we do that process, we get negative 3x plus 9y minus 6z equals 0, because we multiply negative 3 times x times negative 3y and times positive 2z and times 0. So that's my result. And then equation number 3, we just bring it forward, and then we do the operation. So the x's are eliminated, so we get 10y minus 7z equals 7. So this is my new equation 3. And according to the plan, right, to the setup that we had last week, now we're going to get equation 2 and equation 3, and we're going to get rid of the y's. Get rid of y's. So then, here, if we notice, the 20, well, I mean, will be like my least common number that they both can go into. But a lot of times, students have a hard time trying to figure out that number. So I just tell you know what? This one is multiplied by the coefficient on the bottom, and this one multiplied by the coefficient on the top. I mean vice versa. So for example, this one multiplied by -10, and this one by 4. This way you don't have to worry about what the least common number that they have in common. So then, because these two are both positive, one has to be negative. It doesn't matter which one. This could have been 10, and this could have been -4. It doesn't matter. You get the same answer. So by multiplying -10 times every term, we get -40y plus 30z equals to -30. And multiplying 4 times every term, we get 40y minus 28z equals to 28. Now the y's cancel, so we get 2z equals to -2. But I want to isolate the z, have it by itself with no coefficient, so we want z equals to a number, right? So we divide both sides by 2. And it gives us -1. So now we're going to back substitute. This will be equation 1, and I call this equation 2, and this will be equation 3. Now we're going to back substitute. So we start, right, so we already know what the z is. Now we go to number 2 and to solve for y. So we know z is -1, so I'm going to plug in -1 for the z. By doing so, it gives us 4y plus 3 equals 3. So then we subtract 3 from both sides, so we get 4y equals to 0. And we divide by 4, so we know y equals 0. So I already have the solutions for y and z, right? So now I'm going to go to number 1 and plug in the 0 for y and the -1 for z. So y is 0 and z is -1. So we get, this will be 0, so we get x minus 2 equals 0, so we add 2 to both sides. So x equals to 2. So this is my solution of the system. Are you guys doing okay?
Mr. Isasi, there's a question.
Yes.
Giselle asked, could you plug on the new equations instead of the originals?
Let me go back. Could you repeat that? Let me go to the previous one.
Yes, sir. She asked, can you plug in your values into the new equations instead of the originals? That's Ms. Giselle's question.
No, because if you plug it in, for example, when you have the z equals to a number, right? We have this one here. You cannot go back to the originals to 1, 2, or 3 because here we're going to be missing 2 variables. Does that make sense? So that's why we back substitute. So we start only at the end when you have the value for y and z. You can go back. You can plug it into either one when you have 2 values. But here, since we have only the value for z, right? Then we have to go where you don't have no x, it's just y and z. So I can go here or here, it doesn't matter. And then once I have my y and my z, I can go back and plug it into either 1, 2, or 3. But always 1, I mean, will be easier because at the beginning, we set up equation 1 for it to have the coefficient of 1. Did that make sense?
Yes, thank you.
Oh, you're welcome. Okay, I'm going to continue. Okay. Hey guys, keep asking questions, and the moderator will stop me, and then he'll tell me your questions, all right, and then I'll be able to answer them. Okay, now guys, this is number 10. It says convert the linear system of equations into augmented form, then solve by using the Gauss-Jordan method, guys. Hey guys, the Gauss-Jordan method is kind of challenging. Most of the times, it takes students a while for them to understand it. But I kind of modified the way they explained it to a simpler terms, and I've had real positive feedback from students when I explain it in this way that I'm going to present it, because we actually have a plan. On the last presentation, which I did last week, it has the plan itself. But here, guys, I don't have the plan. The plan is It's going to be 3 steps. Okay, and as we go along, I'll show you what the plan is, okay? But you can review the PowerPoint from last week, and it gives you step by step about the plan, how to solve it using the Gauss joint method. Okay, now guys, what does the word RREF stand for? This means reduce row echelon form, which means it's going to be in this form. Let me show you. But to start out, guys, we have to go from linear equations into augmented form. So this is my row 1, right? Because it's 1, -3, 2, and 0. And this is my row 2, which you only get the coefficients. It's 2, -2, 1, and 3. So this will be 3, 1, -1, and 7. So after you work it, this is in reduced row echelon form. When you have all these are 1s across and the rest are 0s, and then this is going to be my answer. This means x equals to 2, y equals to 0, and 1 equals to -1. Okay? But how are we going to do it? Okay, most the books and also many instructors, they have a whole bunch of matrices. They have about maybe 6 or 7 matrices. I only have 3. That's it. But every step, right, has at the most 2 parts. Okay, let me show you what I'm talking about. So I call it my 3-step plan in action. So step 1, I need to make, right, this is called augmented, right? So step 1 is going to go into reduced echelon form. So step 1, guys, these must be zeros here. So these here must be zeros. That's step 1. So that has to be a 0 and also there a 0, right? So how are we going to do it? So if that's a 0, I'm going to use row 1. So it's going to be, again, step 1. So row 1 stays the same. So that has to be a 0 where the 2 is, and also there has to be a 0 where the 3 is. So these two have to change to zeros. That's step 1. And everything is color-coded. So then I'm going to use row 1. So if I multiply -2 times row 1, right, it'll be -2. And then when I add it to row 2, they'll cancel. That's what I'm going to be doing. Same thing on the bottom for row 3. If I multiply -3 times row 1 and add it to row 3, it guarantees to give me a 0 there. And here's my work. -2 row 1 equals to -2 times row 1, which gives me -2, 6, -4, and 0. And then we're going to add it to row 2. Right, so row 2 was 2, -1, 1, 3, and there it is. So if we add them, we get 0, 4, -3, 3, and this is my new row 2. So I repeat the process for row 3. So -3, row 1 is going to be -3 times row 1, which is 1, -3, 2, and 0. You see, I got it from here. So once I distribute, I get -3, 9, -6, and 0. Then I'm going to add it to row 3. So row 3 was 3, 1, -1, 7. So then when I add them, you see, guys, my x's are eliminated, or my x's or the x's on the, these two, which are the x values on the linear system of equations. So I'm done with step 1. On the next slide, I'm going to apply step 2. So I'm going to keep this how it is to start off. Okay, I kept it how it is. Now step 2. Remember, this is my plan here. Now step 2. These two must be zeros, which means, right? Step 2, row 2 stays the same, and that's the -3 must be a 0 in green, and also the 10 must be a 0. So we have to use row 2. So here, guys, to eliminate the -3 there, this one I'm going to multiply. I'm going to multiply 3 times row 2, and add it plus 4 times row 1. And here, guys, like I said, it's going to be -10 row 2 plus 4 row 3. You see, guys, I just get the number from here, I multiply by that one, and the number from here, I multiply by this one. That's what I'm doing here. And here's my work. So 3 row 2 equals to 3 times 0 will be 0, will give us 12, will give us -9, and will give us +9. And then if we multiply plus 4 times row 1, it's going to be 4 times row 1, which is 4 times 1, negative 3, 2, and 0. That's why it's here. So that's what it gives us. Then if we add them, we're going to get 4, 0, negative 1, and 9. So guess what, guys? That's my new row 1. Now I'm going to do eliminate, this one here, the 10. Okay, and this is what I'm going to execute this operation here. So negative 10 row 2, it gives us negative 10 times row 2. You see, there's my row 2, there's my row 2. So once I distribute, I get 0, negative 40, 30, and negative 30. Plus 4 row 3, I'm going to multiply 4 times row 3. There's my row 3. So that's why it's 0, 10, negative 7, 7. So if I distribute, this is what I get, 0, 40, negative 28, 28. Then when I add them, we get 0, 2, negative 2. Hey guys, if you can simplify it as you go along, you're guaranteed to do it in 3 steps. You see, this was step 1, step 2, and step 3. But if you put the 0, 0, 0, 2, 0, 0, 2, negative 2 here, guys, it's going to make your work a little bit more challenging. So it's always wise to simplify as you go along. What does it mean to simplify? We can divide, because this is like my z value, we can divide everything by 2, right? So 0 divided by 2 will be 0, 0 divided by 2 will be 0, 2 divided by 2 is 1, negative 2 divided by 2 is negative 1. So that's my new row 3. Now, on my next slide, I'm going to have all this already set up, but I'm going to be executing my step 3. Again, step 1, step 2, and now comes my step 3 in red. Okay, so step 3, row 3 stays the same, right? Let's look at the pattern. Step 1, row 1 stays the same. Step 2, row 2 stays the same. Step 3, row 3 stays the same. And this is a row that stays the same. That's the one they're going to be using to eliminate the other two. The other 2 entries where you want it to be 0. In this case, I want it, that's going to be a 0, right? Because it has to be 0 and that has to be 0, these 2 here. So here, guys, I can just add row 3 plus row 1. And here, I can multiply 3 times row 3 plus row 2. So here's my work, right? If I just add row 3 plus row 1, that's my result. And again, we simplify every time that we can. Say this was like a 11, I won't simplify yet, okay? Because 11 cannot be divided by 4. But here, guys, since everything can be divided by 4, we go ahead and simplify. So that's what we get, because if we divide every term from here by 4, we get 1, 0, 0, 2. So that's my new row 1. So now we're going to do 3 row 3 plus row 2. So 3 row 3 will give us 0, 0, 3, negative 3. Because I multiplied 3 times 0, 0, 1, negative 1. Plus row 2. If we add them, it's going to give us 0, 4, 0, 0. Because we want all these to be 1s, right? So here we simplify. Again, we divide everything by 4, so it gives us 0, 1, 0, 0. You see, guys, and again, if you follow this method, you only have 3 steps every time, instead of like 6, 7, or 8 matrices. Okay, so this is a method that I modified when I was a student taking this course here. Okay, now. So here are my solutions. So now this one, okay, says solve, but here, guys, I'm going to do it all in one, everything in one. In one slide. So step 1, right? These must be zeros. So that's going to change, and that's going to change. So it will be negative 2 row 1 plus row 2, and row 1 plus row 3. And here's my work. So it's my step 1. So that's what negative 2 row 1, that's what it gives us, negative 2, negative 4, 2, and negative 12. Plus row 2, we just bring row 2 down, and when we add them, 0, negative 5, 5, and negative 5. Here, guys, right? everything can be divided by -5. Because if we leave it like that, it's going to be, the work will be much harder. So we always simplify as we go along. Right, we divide everything by -5, so we get 0, 1, -1, and 2. That's my new row 2. Now row 1 plus row 3. Here we get 0, 1, 0, 1. That's my new row 3. Now comes step 2. So step 2, remember, we're going to use row 2. So row 2 stays the same, and that has to be a 0, and that has to be a 0. Okay, so we're going to do -2 row 2 plus row 1, right? Because -2 times 1 will give us -2. Then when you add it to this one, they'll be eliminated. And here I need to multiply this one by -1, right? To add it to this one, which will give me a 0. So there's my work there. I mean, that's the process that I'm going to execute. Right, so if we distribute, we get 0, -2, 2, and -4, plus row 1, right? And then after we add it, we're going to get 1, 0, 1, 2. So that's my new row 1. And by repeating the process, I'm here for row 3, right? You guys can see what I'm doing there. I'm just going to go a little bit fast so I can cover the other slides. So here we get 0, 0, 1, -1. So that's my new row 3. Now step 3, right? Step 3, row 3 stays the same, and that's got to be a 0, and that's got to be a 0. So this one's got to change. That row's got to change. So here, guys, I can multiply row 3 by -1, right, and add it to row 1. And to eliminate this one, we can just add these. So we can just add row 3 plus row 2. And here's my work. Right, -1 times all these entries, so it's going to give us 0, 0, -1, 1, plus row 1. We just bring row 1 down over here, gives us 1, 0, 0, 3. So that's my new row 1. And I already know that x equals to 3. Now for row 2, right, we just add them. So we get 0, 1, 0, 1. That's my new row 2. If you notice, these are already all ones. There's a 0, so that means x equals to 3, y equals to 1, and z equals to -1. Those are my solutions. Okay. Okay, now, how does this work? 6.3. Again, there's a word problem, guys. So here we have the tickets to a band concert cost $5 for adults, $3 for teenagers, and $2 for preteens. There were 570 people at the concert. The total ticket receipt were 1,150. 3/4 as many teenagers as preteens attended. How many adults, teenagers, and preteens attended? So here, guys, is going to be a system of 3 equations. So we need to find the 3 equations. So we start with, again, people with people and money with money to get the first 2. So we have adults, right? That's people. Teenagers, that's people. And preteens. And there's 570 people total. So if we let x equals to adults, y equals to teenagers, and z equals to preteens, there are 570. So x adult tickets plus y adult ticket plus teenager tickets plus preteen tickets must equal to 570. So it's x plus y plus z equals to 570. Now we do money with money, right? So adult tickets are $5. I mean, what that means, it's going to be 5x, right? Because adults is x. Now for the teenagers, right, it's $3. Since y represents teenagers, so it's going to be 3y. In a similar manner, preteen tickets are $2, and since z represents preteen, so it's going to be 2z. So 5x plus 3y plus 2z equals to the total revenue. So we add those, right? So we're going to add them, and that'll be equation 2. So I found my first 3 equations. We're missing the third one. Most of the times, on these type of problems, the third equation is the hardest one to get. Okay? So we need to find equation 3. And that's my info for equation 3. 3/4 as many teenagers as preteens attended. Okay? That means that teenagers equals to y, right? and preteens is to z. So here only the y and the z variables are being expressed here. So this is my setup here, guys. But doesn't it, using this part here, it says 3/4 as many teenagers as preteens attended. This is what I do, guys. If it is difficult, write it how it sounds. Doesn't it sound like 3/4 y or 3/4 teenagers equals to preteens? Write it how it sounds. And then last time I said you flip it, but I think that was a wrong expression. So instead, I said you're going to switch it. You're going to switch the 3/4 to where the z is. So this is, you see, this is my setup here. But we don't like to work with fractions. So I'm going to multiply everything by 4. So we get 4y equals to 3z. But I have to set it up, and x plus y plus z equals 0, right? Equals to sum to a constant. So the z has to go to the left side. So I subtract 3z from both sides. So I get 4y minus 3 equals 0. So that's equation number 3. So those are my equations. So on the next slide, I'm going to solve it. You could solve it by matrix, or by when I show you guys the first slide on this section, where you do equation 1, equation 2, get rid of the x's, right? And equation 1, equation 3, get rid of the x's. So that's what I'm going to use. Or you can also plug it in the calculator by using matrix. I'm going to show you how to do that in a slide coming up. Okay. So again, we do the same process as before. We get 1 and 2, get rid of the x's. So this must be multiplied by -5. In doing so, it gives us -5x minus 5y minus 5z equals to -2850, because I distribute the -5 times every term. Here, I'm going to multiply it by every term. And row 2 says how it is. Right after we add them, guys, the x's were eliminated. So this is new equation 2. Equation 3 is set with no x term. So the equation 3 is already set up. So now I'm going to get equation 2 and equation 3. Because this one, guys, is like one less step to do, because there's no x's. The x's, they were eliminated. So now here, I'm going to get rid of the y's. So the equation number 2 multiplied by 2. Why 2? Because 2 times -2 will give us -4. Then when added to 4, they're going to be eliminated. Okay, but I have to multiply 2 times every term. So if I add them, we get -9z equals to -1800. We divide both sides by -9. So z equals 200. Now here, guys, right, we're going to back substitute. And again, I could have put here for equation 2, I could have put this one here, right? Equation 3 or equation 2, it doesn't matter. But once I have z equals to something, I have to go back to the equation that only has y's and z's, because this way I can solve for y. Okay. So I'm going to plug in 200 for z. Once I do that, I get -2y minus 600 equals to -900. So I add 600 to both sides, so -2y equals to -300. We divide by -2, so y equals to 150. Now I have equate y and z, right, the values. So I'm going to plug them into equation 1. There's my y, there's my z. So x plus 350 equals to 570, so I subtract 350 from both sides. So if I do that, 350 minus 570 will give us 220. So here's my solutions, right? But what does that mean? Adults are 220, teenagers are 150, and preteens are 200. This one, you can also solve it by using the Gauss-Jordan method. But I know that a lot of students, they don't like to use that method because it's kind of challenging, okay? But if you practice it, guys, over and over again, it's going to be beneficial, the Gauss-Jordan method. And also go over the slide from the PowerPoint from last week, because it has more the steps and everything there. Okay, now, this comes matrix addition, 6.4. So here, guys, we're going to be adding the matrix, but to add them or subtract them, they have to be the same size. This is a 2 rows by 3 matrix. This is also 2 by 3. This is 2 rows and 2 columns, 2 by 2, 2 by 2. So we have to indicate, so we have to do this operation here. Can we add A plus B? Yes, because A is 2 by 3 and B is 2 by 3. So I'm going to add the first entry is this, is that the location will be A11 because A11 means the first row, first column. We're going to add it to B11 because on row B, on the matrix B, B11 means that it's going to be the first row, first column. So we're going to add these. We're going to add these right here, right? And we're going to add these right here. And then we do also the ones at the bottom. And then negative 2 plus 4, right? So it'll be 7, negative 1, 7, 0, 5, and 2. But you don't have to go, you can do it, straight from here. 5 plus 2 is 7. Negative 1 plus 0 is negative 1. 6 plus 1 is 7. 3 plus negative 3 is 0. 4 plus 1 is 5, and negative 2 plus 4 is 2, right? You can do it that way too. How about C plus D? Can we add them? Sure, because they're the same size. Right, so we're going to add these two, and these two, and also these two are here, the negative 5 and 8, and the 0 and the negative 6. So we get 5, 0, 3, and negative 6. How about C plus A? Can we add C plus A? C is a 2 by 2 and A is a 2 by 3. We can add them because these two are not the same size. And again, to add and subtract, they have to be the same size. Not possible, not the same. So now we're going to subtract them. So A minus B. Okay, so it's going to be 1 minus 8. Okay, I'm going to go kind of fast, guys, because I'm running a little bit of time. But we do the same process, guys, right? So what's next? 2 minus 1, 2 minus negative 1, 2 minus 3, negative 1 minus 4. So it's going to give us negative 7, negative 3, 1, 3, negative 1, negative 5. Now C minus D. Again, this is the same size, so we can execute the operation. So 5 minus 2, 1 minus negative 1, negative 4 minus 9, 3 minus negative 7. So we get 3, we get 2, we get negative what? Negative 13, and we get 10. Can we do A minus C? A minus C are not the same size, so it's not possible. Not the same size. Okay, now, are you guys okay? So here we have negative 4a. This is a scalar multiplication. So that means I'm going to multiply negative 4 times every entry in the A matrix. And again, this is only to show the work, but you go straight, straight. Negative 4 times negative 2 will give us 8. Right? You can go, this is to show you what's taking place, but you can just go from negative 2 to negative 4 times negative 2 is 8. Negative 4 times 0 is 0. Negative 4 times 5 is negative 20. Negative 4 times 3 is negative 12. Now let's do 5b. So again, this is a work, so you guys can see what's taking place. But you can go straight from here to the answer. 5 times 0 is 0. 5 times 2 is 10. 5 times 4 is 20. 5 times negative 6 is negative 30. And then we're going to add negative 4a plus 5b. So negative 4a, right, this was my answer. Plus 5b, for 5b, this was my answer. Now we do what we did earlier, right, when we had matrices. So 8 plus 0, 0 plus 10, negative 20 plus 20, and negative 12 plus negative 30. So we get 8, 10, 0, negative 42. That's my result. And most teachers are going to give you something like this on the exam, because I always gave something like this on the exam. Maybe not A and B, but we'll give you something like negative 4a plus 5b. But here, guys, I just put negative 4a and 5b. That way, I don't have to do it here again. That way, all the work is here. Now, to multiply. To multiply, like I said last week, I believe I have an easier method to do it, but it's hard to put it in a PowerPoint. So here I'm just going to do it the way the book does it. So for a matrix, right? Matrix B is a 2 by 2 and matrix A is a 2 by 3. In order for you to execute the multiplication, the two inner numbers must be the same, right? So yes, a match, and the answer will be the outer numbers, the 2 by 3 matrix. So step 1, right? I'm going to use row 1 and multiply times every column. That's why I'm going to multiply the ones in blue times the ones in red. So 1 times 2 plus 0 times 4 gives us 2. So the 2 goes there. Step 2, now since I'm done with this column, now this one's going to be the one that's in red. Now I multiply the 1 times 0 and 0 times -2. Right, so the answer is 0. Step 3, now these are going to be the ones that I'm going to be using to multiply, so those are going to be in red. I'll repeat the process. 1 times 5 is 5, right? 0 times -3 is 0. So when we add them, it's going to give us 5, so 5 goes there. If you notice, there's no more columns to go, right? So that means that now we're going to use the row 2. You see, and we're going to start the process all over again. Now we're going to start with the first column, and we keep repeating the process. This is going to give us 0, so the 0 goes right there. Then step 5, right? So now, so it's going to be this row times this column here, times the 0, -2. 4 times 0, -2 times -2. So it's going to give us 0 plus 4, so the 4 goes there. And lastly, right, it's going to be the second row times the last column. 4 times 5, -2 times -3 is going to give us 20 plus 6 is 26. So that's my answer, guys. Okay. Now, for the inverse matrix. Hey guys, this is an I, okay, it's not a 1. The I stands for identity. So for the inverse, right, the inverse, I'm gonna do the reduced row echelon form or the Gauss-Jordan method by making that a 0, and this is 0, and then this is gonna come over here, and then whatever's on the right side is your inverse. Okay, I'm gonna use the Gauss-Jordan method for the matrix. So this should be my answer. Okay, but let's execute it. This is my inverse. Right, so here we start. Row 1, row 2. Remember, guys, in a 2 by 2 matrix here, guys, right? Because this is the inverse, right? So here, these must be ones here. So that must be a 0, and that must be a 0. So this one's gonna change the second row. So -4 times row 1 plus row 2. And here's my work. It's going to give us -4, -8, -4, and 0, plus row 2 gives us 4, 6, 0, 1. When we add them, we get 0, -2, -4, and 1. Here, guys, it's not wise to divide everything by -2 because this is a 1 there. And then if we do that, it's going to give us a fraction. So we try to eliminate the fractions as much as we can. So that's my new row 2. Now this one must be a 0 now, right? Because remember, these must be 1s, but don't worry about that for now, about the -2 here. We'll make it 1 later. So these two, we can just add them. Here's my work. We get 1, 0, -3, and 1. So that's my new row 1. But check this out. This has to be a 1, right? So now we multiply by -1/2 because with matrix, guys, we don't divide. We multiply by the reciprocal. So that's why the reciprocal of -2 is -1/2. So we multiply -1/2 times every term there. So -1/2 times 0 will give me a 0. -1/2 times -2 will give me a 1. -1/2 times -4 will give us a 2. -1/2 times 1 will give us a -1/2. So guess what, guys? There's my inverse. Okay. Now I'm going to do it another way, but I believe I'm going to do another problem, but there's a formula for the inverse, right? Only for a 2 by 2 matrix. If you have A equals to A, B, C, and D, right? The inverse will be 1 over A times D minus B times C. This is called a determinant. They don't put too much emphasis in 1324, but in 1314, they put a lot of emphasis on the determinant. But it's crucial for future math courses. So then we switch. These two become different signs, if you notice. Different signs. And you switch you switch places with the A and the D. So find the inverse of this matrix here. So it's going to be, right? So it's going to be 1 times 6 minus 2 times 4. So this is equal to negative 1/2, correct? Because 6 minus 8 is negative 1/2. Now we multiply negative 1/2 times every term. And if you notice, it's the same one as we did earlier. You see, guys, we did the same thing. So you have another way to get the answer by doing it this way or by doing it the way I did it with Gauss-Jordan method. Now, this is how you plug everything in the calculator, guys. I know it's almost time. We got about 2 minutes, but let me see. I'm going to try to finish everything here. Hey, guys, to start off and plug in a matrix, in a TI-84, TI-83 calculator. So you go to second and then matrix. The matrix is going to be the inverse key, right? So that's what you hit, and then you're going to go to you see I'm doing it as I go along. Second matrix. If you have a calculator, please follow along to make sure that you do get that you do know how to do it. So second matrix. Then you're going to go to edit, right? You're going to go to edit. Then you're going to put enter. Where is that it is? You're going to enter. Then you can enter the size of the matrix and all the entries. After each entry, press enter. So for example, if you're doing a 2 by 3 matrix, you put 2, enter, 3, enter, and then it's going to give you the matrix already set up. And then all you do is enter the entries, but you enter them one at a time. And after you enter it, you put enter. And then say you put 4, and then enter, and so forth. Then you're going to go to second quit. When you go to second quit, your screen, the quit button is in blue, right? That's why it's a mode key. It's going to be, the screen should be blank. Okay, now here it is. If you're solving the system like the use echelon form, right? Like the Gauss-Jordan method, then you follow the steps here. Again, you're going to go to second matrix. Then you're going to go to math. Then you're going to go down to RREF. And then you're going to enter. Right? You're going to RREF and you're going to enter. Now, here you have a choice, right? Then you're going to go get the matrix. Second matrix. And here, guys, choose the matrix being solved. Because in your calculator, you can actually put up to like 7 matrices. So therefore, students make mistakes because they put the matrix on top of the matrix. Okay, guys, so don't do that. Make sure that you have them matrix A, B, C, and so forth. So let's pretend, right, then you enter, say, let's pretend that it was matrix A. So once you enter, you will get the matrix and say it was matrix A. Then you close the parentheses, and then you enter, and then you get the answer. Say the matrix was a 2 by 3, this is what you would see on your screen. But these are numbers here, guys, okay? This means X equals to A and Y equals to B. That's how you do it. Solving, but say you want to just put a matrix in there. Say you want to put a matrix like matrix A, matrix B, because you want to add them or whatever. You stop here. You do only this part here, and you second quit and you stop. Then you repeat the process to enter another matrix. But make sure, be careful, do not use the same location to enter additional matrices. For example, if you go to say you already put something on matrix A. So when you go to edit, make sure that you go down to matrix B, because if you don't do that, it'll replace what you're going to put right now into the matrix A. Okay, and there's also a website, guys, that you can log into how to enter a matrix in a TI-83, TI-84 calculator, and they have even videos. Okay, then you scroll down and use other locations for additional matrices. Now solve the matrix equation using the AX equals to B. So solution. Hey guys, here guys, to get rid of the A, you get the inverse. You don't divide by A, because the matrix says they cannot be divided. So you multiply by the reciprocal, which is the inverse. So you multiply both sides by the reciprocal, right? the inverse of A, you also have to put it in front of the B, of the B matrix. So this is my solution. You need to find the inverse of matrix A. So using the inverse formula, right, from the 2 by 2, right, matrix formula, right, you should get this right here. If you put that in there, you should get that. Or you can put this matrix in the calculator, right, and then go to second quit, and then the screen will go blank. Then go get the matrix and get the inverse key, and it'll give you this right here. If it gives you a decimal, hit the math key, hit it, and then hit it twice, enter, and it's going to give you a fraction. Again, you can look it up on YouTube. So then here, guys, right, this is to find x, we get the inverse times b. This is the inverse, and this is the b matrix. So to multiply, I'm going to multiply this row times this column. So 5/3 times -3 will give us, this will be the answer of 2 by 1, but it's going to give us 5/3 times -2 will give us -15/3. And then -2/3 times 5 will give us -10/3. If we add them, it's going to give us -25/3. And that's the first row, first column. Then we multiply -1/3 times 3. It's going to give us 3/3. Then we multiply -1/3 times 5. It's going to give us 5/3. If we add them, it's going to give us 8/3. And this is the answer for x and the answer for y. Okay. Now, this one, guys, I know it's already almost time. We already passed it. But let me continue how to set it up real quick. Okay. Solution. This is 6.6. Let x equal number of days, and let y equal number of miles. It says a budget truck rental charges $19.99 per day plus 59 cents per mile to rent a 12-foot moving truck in Austin, Texas in 2016. The total bill for your move was $86. The rates for a local moving company were $10 per day and $95 per mile. And the bill for the same trip, same number of miles and the same number of days, would have been $94.10. How many miles and how many days were the trip? So you let x equal to number of days and let y equal to number of miles. So here's my first equation, right? So this is x, right? Because x will be the days and this will be y. And this will be the revenue, 86. My second equation, it's 10 days, 95 cents per mile. And that's my total revenue. So it's going to be 10x plus 0.95y equals to 94.10. Now here, guys, you can actually do it by this one. It can be done by graphing, by substitution, by the addition method, by matrix. Now they want you to do it by using the inverse coefficient matrix. So they want you to do it this way. That's matrix A, the coefficient matrix. This represents B, the x and y, equals to B. This is my B here, guys. So for the inverse, you can actually put that in the calculator, guys, and get the inverse of A. So that's my inverse. If you put that in the calculator, guys, and then press the inverse key, or actually do the work, this is what you should get. That's my B matrix. Then this should be your result, which means 2 days and 78 miles. So the trip was 2 days long and 78 miles. Hey, guys, I believe that's it. There should have been like a link here, but I didn't get it from the Chuka. But Patricia, could you put the link for the survey on the screen, please? And for the students that actually don't
it's in the chat, Mr. Zossi.
Oh, it's in the chat. Okay, thank you. For the students that actually weren't able to participate in this workshop, they can get credit by answering these questions. And Patricia, could you also put that link here on the PowerPoint that I sent you? This way they can also get credit. Okay. Hey guys, thank you very much for being patient with me, and also for staying this long, because I passed it by 7 minutes.
Thank you, Mr. Zossi.
Thank you, Gazelle. Thank you, guys. Hopefully this PowerPoint makes sense, guys. Okay, thank you very much. Hey guys, I gotta go because I have another commitment that I do every Friday. Okay, I have to go to another. I have to go volunteer. Okay, so thank you very much, guys, and I'll see you next week. Thank you.
Thank you very much, Mr. Isasi. We want to thank you for this presentation. I know you're about to take off. Also, guys, we wanted to take this time to remind you guys and invite you to next week's Happy Math Hour. It's going to be about sets, also presented by Mr. Isasi. Also, just to let you guys know, there's tutors around. If any of you have questions or want to ask us something to a tutor, you can always let us know. Other than that, if you don't have no more questions, then this concludes our Happy Math Hour for today, and you're free to go. Like I said, if you have questions, let us know, and because we do have tutors available that can help you guys in a private room. But other than that, you have a good one. Best of luck to you guys who haven't taken your test yet, and to those who did, well, thank you for assisting today session. Like I said, next sessions will be on set next week. But other than that,